Now, before we discuss the application of recurrence relations in determining the time complexity of algorithm, it's important to know about the big O notation. Now, the big O, or which is represented like this, O and a function of n, um, is an equation that describes how the runtime scales with the size of input data. And here n represents the size of input data. And to get a simplified idea of this, let's say we have a code or an algorithm in which we have to calculate x plus y, and let's say x and y both are constants, and since it's just one step, this entire thing has a complexity of 1. So this entire procedure, its big O notation is O of n. Then likewise, if we have a for loop where I is ranging from 0 to n, and then let's say we are printing I. So this entire thing, since it happens n times, therefore it has an order of n, so big O of n. Likewise, if we have another kind of a code where, let's say, we have a loop within a loop, I is ranging from 0 to n, and then within this we have a for loop where j is ranging from 0 to n, and let's say we are printing I times j. So this entire thing will happen n square times, so the order is O of n square. Now let's assume that we have a code which has this part in it, and it has this part in it, and it has this part in it. Then we can say the time complexity here, it gets added n square plus n plus 1. But in that case, the highest power becomes dominant, and we say that the time complexity of this entire algorithm is of the order of n square. Now similarly, if we have some other functions, big O functions, let's say we have log n, then its runtime or growth is less than the order of n, or big O of n, and that in itself has is less than its dominance is more, or the big O of n log n is its dominance is more than big O of n, and likewise the big O of n square is more than order of n log n, and so on. So whatever is the highest power, that becomes dominant in the algorithm, and that's how we represent the time complexity. And there are different ways to measure the time complexity or space complexity. One is called as the average case, another is the worst case, and then we have the best case. Now in this case, big O of n uh, usually represents the worst case. Now that's a brief overview of the big O of n notation. Now in next videos we'll discuss the how recurrence relations help in determining the time complexity of different algorithms.